Linear regression analysis. The least squares method. The least squares method is a way of finding the equation of a straight line that best fits the data that's been given to you. Once your line is drawn, you can then make accurate predictions about the dependent variable for any value of the independent variable. The equation that you find is called the regression equation. And when you draw a graph from the regression equation, it's known as the regression line. Now you already know that the equation of a straight line is y equals ax plus b, where x is the independent variable that will be given to you, y is the dependent variable that is also given to you, a is the slope of the line, and b is the y-intercept, where your line will cut the y-axis. Now, in order to find a, we use the following formula. A equals n, which is the number of values given, multiplied by the sum of xy, minus the sum of x multiplied by the sum of y, divided by the number of values given you multiplied by the sum of x squared, minus the sum of x all squared. And similarly, b, we use this formula. B equals the sum of x squared multiplied by the sum of y, minus the sum of xy multiplied by the sum of x, divide by the number of values you're given multiplied by the sum of x squared, minus the sum of x all squared. Now don't worry, you will not have to remember those formula. They will be given to you on your formula sheet. Now to use the least squares method, we follow the 5 steps below. So, step 1, you must first decide which variable is the dependent variable, and this will be the y-axis variable. Step 2, using the data that's given to you, you draw a simple scatter diagram. Then step 3, if the scatter diagram shows a reasonable relationship, you can then go on and find A, the slope of your line, and B, the y-intercept. Following on from this, step 4, you work out your regression line, and step 5, you can plot your regression line on your scatter diagram, and you will be able to predict any value of your dependent from your independent value. Let's have a look at an example. Here we've got data showing the number of flu jabs given with the number of people who have the flu. So when 7 flu jabs are given, 62 people suffer with the flu. When 9 flu jabs were given, 60 people were seen to suffer with flu. So, step 1, what is the dependent variable? Well, if you think about it, the number of people with flu depends on how many flu jabs are given. So the number of people with flu is the dependent variable. Now let's go on to step 2. Draw the scatter diagram. There's our scatter diagram. We've got the dependent variable on the y-axis, number of people with flu, and the independent variable, the flu jabs given, on the x-axis. So when the number of flu jabs was 7, about here, then the number of people with flu was 62. And when the number of flu jabs were 9, the number of people with flu were 60, and so on. So let's go on to step 3. Does the scatter diagram show a reasonable relationship? Well, yes, of course it does. It shows a strong negative correlation. As the number of flu jabs increase, the number of people with flu decreases. So this is a strong negative correlation. And following on from step 3, if the scatter diagram shows a reasonable relationship between the two variables, you can make a table and use the 2 formula I showed you in the previous page to find A, the slope of the regression line, and B, the y-intercept. So, in my table now, I've added two more columns, x squared, so 7 squared is 49, 9 squared is 81, and I've also added x times y, so 7 times 62 is 434, 9 times 60 is 540, and so on. Now, you'll notice from the formula that we use to find A that we need the sum of all these columns. So let's find the sum of x, so they're 258, the sum of all the y's, 483, the sum of all the x squared, 9,244, and the sum of xy, 13,189. So now we just substitute our values into our equation. So the number of values is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 multiplied by the sum of xy minus the sum of x multiplied by the sum of y, divide by the number of values, which is 9, times the sum of x squared minus the sum of x all squared. Now, if you put that in your calculator, you'll find that A equals minus 0.36 to 2 decimal places. Now, what exactly does this mean? Well, the negative confirms that the slope is a negative correlation. So the slope of the regression line is negative. The number of people with flu will decrease by 0.36 for every increase in one flu jab given. Okay, let's go on and find the y-intercept, the B, the y-intercept. So once again, we substitute all our values. So we've got x squared, the sum of x squared times the sum of y minus the sum of xy multiplied by the sum of x. Divide by the number of values times the sum of x squared minus the sum of x all squared. Put that into your calculator and you'll find that B equals 63.86. So what does that mean? Well, simply it means the y-intercept is at 63.86. So when x is 0, y will be 63.86. And this means that approximately 64 people are likely to get flu when 0 flu jabs are given. So now we know the slope is minus 0.36 and the y-intercept, B, is 63.86. We can now do step 4, determine the regression line. So, using y equals ax plus b, we're going to substitute for a and b. So y equals minus 0.36x plus 63.86. Now we're going to choose a value for x of 0. So if we put 0 in place of x, all of this will become 0. So y is simply 63.86. So when x is 0, y is 63.86. So let's plot that on our scatter plot there. Next, I'm going to choose a value of y equals 50. So when y equals 50, I will put, instead of y here, 50. So minus 0.36x plus 63.86 is equal to 50. Now, why did I choose 50? I chose a value of y that was within the range of my values, and my values ranged from 48 to 62. So that's why I chose 50. It would be no good choosing 30 because we have no values at 30. So I chose 50. So rearranging this equation, when y equals 50, x equals 38.5. So let's plot when y equals 50, x equals 38.5. Finally, Let's draw the regression line on the scatter diagram. And the regression line must pass through these 2 points here for it to be accurate. So we draw in our regression line, and we can see, or we can confirm, that it is a very strong correlation because many of the points are actually touching or on that regression line. So using this regression line, you can now predict accurately any number of people that are likely to get flu depending on the number of flu jabs that are given. Thank you.